Hey folks, since in the previous session we have touched upon what exactly the t-SCENE visualization. So in this session, let's try to implement this t-SCENE visualization. So if I will say df.columns, just to cross check all the columns that we have. Now from this, let's try to implement this t-SCENE visualization on top of, let's say, all these set of features what I have selected. Let's try to implement the t-SCENE on top of this. Again, in general, t-SCENE is nothing but it's a dimensionality reduction technique. It's a dimensionality reduction technique. It means we're just trying to visualize all these features. Let's say we have 1, 2, probably 5, 8, 10. We have typically 15 features. So let's try to visualize this, let's say in 2D space or let's say in 3D space. So just to understand more about a feature, here comes an interesting visualization, often known as t-SCENE visualization. Again, for those of you who do not know what exactly is a dimensionality reduction or what are the techniques of dimensionality reduction, what actually stands for t-SCENE, I will extremely recommend you just to check out my previous video. Again, as all the 15 features values, varying a lot. So let's try to scale it. First and foremost, let's try to scale all those features. Let's say if I will pick, let's say, two random features. Imagine fuzz ratio and let's say CSC min. Let's say CSC min and fuzz ratio. So fuzz ratio might fluctuate between 0 to 100, whereas your CSC min might fluctuate between, let's say, 0 to 1. So both the features are varying, but one of the major concern is they are varying on a different scale. This is one of the major concerns. So just to make all the stuff on same scale, you have to use some scaling techniques on top of the data that we have. So let's try to implement something known as min-max scaler on top of the data that you have. Again, for those of you who do not know this min-max scaler, I extremely recommend you just to check out the previous video that I have with respect to min-max scaler. So I will say first and foremost, let's try to import all the stuff that is extremely helpful for us just to implement this min-max scaler. You have to import this pre-processing. Now from this, I will say just import a class which is all about min-max scaler. Cool. Now first and foremost, let's try to initialize a class or let's try to create its object. Let's say the object is all about imagine scale. Cool. Let me execute this line of code. Using this scale, you have to call an inbuilt function which is all about fit_transform. Now here you have to pass all the feature. Here my feature is all about nothing but all these set of features. Cool. Now if I will say df of all these features, the moment I will execute, you will end up getting all the different data set where you have 15 features. Now let's try to visualize all these 15 features using 2D space or 3D space. So here your t-SCENE comes into picture. First and foremost, you need to scale it. Cool. The moment I will execute this line of code, now you will see you will end up getting an array where all the values are exactly in between some range, probably between 0 to 1 range. So let's try to scale or let's try to store this value. So I will say x. Cool. Similarly, first and foremost, I have to store something known as isDuplicate somewhere else. So I will is duplicate dot values. Just to convert this into an array, you have to use a dot values on top of this. Cool. Let me store this in y. Cool. Now what I will do is I will say from this scikit-learn dot manifold, you have to go inside this submodule which is all about manifold. I will say from this, hey, can you import something known as t-SCENE? The moment I will press tab over here, this is exactly that. This is exactly the visualization. So let's try to initialize this t-SCENE. I will say, let's try to press shift plus tab over there. You will see by default, these are all the parameters that we have. Again, number of components by default, it is 2. It typically means I need 2D space or I need visualization in my 2D space. Cool. Again, there are tons of parameters over there, tons of parameters we have. Now look at the documentation string that we have. It says, hey, t-SCENE is just a tool just to visualize the high dimensional data that you have. It just converts the similarities between data points to joint probabilities. Now what I will do is I will say, hey, cool, let's try to consider the random state value. Let's say 101. Let's say 101. And cool, along with, hey, can I set some verbose value? Again, verbose is all about nothing but just to showcase all the step-by-step execution in the cell that you are getting. Cool. Now let's try to store this. Let's say tsne 2D. Let's say tsne 2D. Cool. And very fast, let's try to execute it. Now using this tsne 2D object, I have to call something known as fit underscore transform. Over here I have to just mention our x, which must be in the form of scale. So I will say that's all about our x. Cool. The moment, and let's try to store that somewhere else. So I will say, let's say it's all about nothing but imagine tsne 2D. Cool. The moment I will execute this line of code, first and foremost, let's try to remove this, and the moment, and I will say cool. It is all about the equal, and let's execute this line of code. Now you will see it starts executing, and you will figure out you are getting all the output or all the execution just because of the verbose equals to 2 stands for. That's what actually verbose equals to 2 is doing over here. Now you will see all the stuff gets successfully executing. Along with, you will see this is iteration 50. It takes that much time, and the next 50 iteration takes that much time. Again, in your cell it might take some different execution time. It entirely depends upon your system specifications and lots of other dependencies. So if I will say tsne of 2D, let me execute this line of code. Now these are all the tsne values that I will end up getting. Now let's try to create its data frame. So if I will say pd.dataframe, and the moment I will pass this tsne 2D, let me execute. This is a data frame that I will end up getting. Let me store this in somewhere else. Let's say in df2. Cool. Let me execute and let me print it. Let's try to assign own column name. So I will say df2.columns, and let us assign own column name. The first is all about let's say x. The second is all about, let's say y. Cool. And the moment I will execute, and if I will say df2, this is what I will end up getting. Now let's try to insert the output feature, which is all about is duplicate. So I will say df2 of, let's say, label, and what I will do is I will say df of is underscore duplicate. Cool. And if I will say df2, let me execute. This is what you will end up getting. Now considering this data frame, which is all about df2, I can showcase our visualization. So just to showcase it, I have to use something known as lm plot. The moment I will press shift plus tab over there, look at all the parameters that we have, and in general what it does is it plots the data and the regression model that fit across the faceted grid that you have. That's what it does. So I will say data is nothing but our df2 that I have created over here. Cool. And x is all about the x feature that we have. Similarly, the y is all about the y feature that we have, and along with that we have some fancy parameter which is all about fit regression, and I do not need our regression line, hence fit regression equals to false. Along with that, if you want to set your own size, I can say size is all about, let's say, 8, and in case you need to set your own markers, I will say markers is all about, let's say, some S and some O. Again, these are typically the notation of the markers that you have. Let me show that. If I will press shift plus tab, look at the parameter. Let me show you. Cool. Yeah, by default it is O, and if you will go through its documentation, it says, hey, it just use a matplotlib marker code or all the list of marker codes that you have. That's why passing all the markers in the list makes a lot of sense over here. Now, cool. Let me execute this line of code. But first and foremost, you have to take care of a very important parameter, which is all about our hue. It means considering what feature, you have to split your visual. So I will say hue is all about nothing but is duplicate, or even you can think of your label feature as well. Cool. Sounds good. The moment I will execute this line of code, now this is what you will end up getting. This is basically your 2D space. Again, just to make things more simple, or just to assign some title, I will say plt.title. Imagine title is all about nothing but perplexity. Let's say perplexity. Let's try to receive its value from my format function. I will say it's all about this placeholder, and of course our some maximum iteration. Let's say maximum underscore iteration. Cool. Again, by default, let me show that. If I will press shift plus tab over there, by default maximum iteration is is basically over 1000, and by default perplexity value is all about 30. Let's try to print that just to make things more user friendly. I will say it's all about nothing but cool, max iter cool and dot format. Cool. The format value says 30. The second placeholder goes to 1000, and let's try to show this. So I will say plt.show, and let me say it is all about show. Cool. Let me execute this line of code. Now you will see this is the perplexity value, and these are the maximum iterations that you have, and this is basically your visualization. Now from this we can say, look at the region. Look at this region we have. It means there are a lot of region. There are a lot of region in which, or if I will talk with respect to class 0, there are a lot of region where they can be distinguished easily. Of course, there are some reasons where it cannot be distinguished easily, but there are some reasons where it can be distinguished easily. So the inference is all about as in some of the scenarios, as we have some kind of overlapping, hence these 15 features up to some extent they are useful. Hence we can consider these 15 features for our machine learning model stuff. That's what it generally says. Again, even if you want to showcase your T-SNE visualization in the 3D space, you can do that. You have to just modify the n components value to 3 and you will end up getting. That's not rocket science. So that's all about it. Again, for those of you who have any error, please feel free to ask with us in the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.